Um,
I'm worried really about how much.
okay. So, as I was looking through a lot of people's homework, I know Gia did it in a card. She got it right. Um, that's good. I know. Austin, did you get the right answer? No, right?
No, but you already messed up.
Okay, you know where you mess up. Amber, do you know where you mess up?
Yeah.
Okay. Did you figure out both questions or no? There's only one.
Just the one. Second one. Oh.
Okay. Um, I know Matthew was here after school. He figured out his thing. Aiden, you might have to relinquish your seat soon if you don't do your work. Back to
Once.
Matthew. Peter did it on his own. Uh, Amira tried and did not succeed. Kind of. Okay. And she was embarrassed for me to see it. But that's okay. So the thing about it is in every class I will assign a group leader, I will assign certain things. It's not saying that they will get their answer correctly. No. And matter of fact, a lot of times I see kids who are good at helping. I see people put in a lot of effort, or I see there's a talent there. In this class, it's a little bit mixture of a little bit of both. So it's not, sometimes the non-group leader, in this case, like Matthew is work a little bit harder than Aiden this time. But I will say it's not always about the right answer. And I'm gonna explain to you with this video. I love Neil deGrasse Tyson. Do you know who he is? Do you know what he does? What he does? Astro what? Physicist? Okay. I don't know like what did he do on astrophysics to be honest with you, but I always thought he's a great motivation speaker. Fantastic motivation speaker. And explain in a way that where everybody understand. So a lot of you guys are so worried about how do you get an answer correct. Well, how do you know the answer is correct? First of all, you can always check on Desmos, right? I saw Wim last period trying to help out Nathan, trying to tell him that his answer is wrong, and he proved it by showing up on Desmos. So there's a work that need to be fixed. I love Wim. Wim is always helping another student. He sometimes mess with Laura, but he's a good kid. He's a good kid though, right?
He's a great kid.
He's a great kid. Yeah, he's no, he's a fantastic person. Also in first period, I saw 6 group leader. In this class, it's kind of hard to differentiate because I feel like this class have a lot of progression still need to be made. So I know Laura make a lot of progression on the last test, and I know Makita's making the progressions. I know Aiden's making a progression. Matthew's making. Matthew need a clutch up on the test, but he's making progression. Believe it or not, Peter's doing good. Peter probably didn't do as good on this test, but he's fine. But yeah, there were certain people that they make improvement. What I'm trying to say is not always about the right answer. So when you show me the right work, doesn't mean that you understand it because it means you copy from another person, right? So let's look at this video together, and I need you to pay attention to this video.
I'm worried really about how much
Sorry.
fuzzy thinking is going on in the world. You know, fuzzy thinking, people are just not thinking straight. Consider this following example. Imagine you have a spelling bee. And this is contrived, but it makes the point. This is a spelling bee, and you have to spell the word. So one student spells it C-A-T. Person got it right. Next person spells it K-A-T. That's wrong. You got that wrong. Third person spells it X-Q-W. You realize that is marked equally as wrong with the K-A-T? When you could argue that K-A-T is a better spelling for cat than C-A-T. Dictionaries know this because that's how they spell it phonetically. And so we've built a system for ourselves where there is an answer and everything else is not the answer, even when some answers are better than others. So our brains are absent the wiring capable of coming up with an original thought. If you're an employer and two candidates come up looking for a job, and this is, again, a contrived example, and you're interviewing the two candidates, and you say, for part of this interview, I just want to ask you, what's the height of the spire on this building? And the candidate says, oh, I was an architect. I majored in architecture for a while, and I memorized the heights of all the buildings on campus. I know the height of that spire is 150 feet. That's 155 feet tall. It turns out that's the right answer. That's the right answer. And the person came up with it in second. That person goes away, the next candidate walks in. But do you know the height of the spire on this building? The candidate says, no, but I'll be right back. The person runs outside, measures the length of the shadow of that spire on the ground, measures the length of her own shadow, ratios the height to the shadow, and comes up with the number. Runs back inside, it's about 150 feet. Who are you going to hire?
Do you see what he's trying to get to? It's a person. I feel like a lot of you guys trying to memorize how to do a problem, and that's the problem. Is you trying to memorize how to do a problem. There are a lot of people who figure things out. And let's talk about who figured things out. Why did I give you those two questions? Well, extra credit questions. And let me interview some of you guys, right? So, the way I'm gonna think about it is this. So, what happened is, when you see those two questions, how many kids look at this problem with fear? Raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 kids out of probably 17, 18 kids here that start with a problem with the fear of, I don't believe that I can do it. How many of you guys have overcome the fear? Raise your hand. Not a single one?
What do you mean overplay?
Like, just say, you know what? Fear, I don't let fear control me. I like Ava. Ava's a good attitude. That's why I know she's going to be a great basketball player someday. Not a mathematician.
Not math. But
Not math, but great basketball player. Okay. Ember? You overcome it? The fear?
I think so, yeah.
Okay. All right. That's good. The problem is you guys treated those two problems as a problem. it's not a problem. It's opportunity. Do you ever realize that it's opportunity for you to prove yourself, right? I'm going to tell you a dating advice. You should not be like, oh, this person is out of my league. I cannot do it. She's too hot for me. There's no way I have a shot at it. Or this boy is too good looking for me, too handsome. You have no shot. I'm self-conscious. I'm not good enough. You have to go says, hey, my name is Donald Ye. What's your name? You have to go up says, you know, that's how you get a girlfriend. That's how you get a boyfriend. You cannot let fear control you, because that's opportunity instead of problem. And also, it's not to memorize how to do something. Not to, hey, teach me how to do it. Let me memorize how to do this question. Hopefully you put on the test. That's not the way to do it. It's to do it is like the person who figure things out on the spot. I don't know how tall this building is, but I'm going to run outside. I'm going to measure my shadow. I'm going to go outside, measure the shadow of the building. And I'm going to figure out using similar triangle. That's what I'm looking for. I'm looking for the person who can figure things out. And it is okay if you did not figure it out. It is fun. It is okay that you cannot figure things out. But at least you give yourself 15, 30 minutes to look at it. You cannot just say, oh, I cannot do it. It's too hard. A lot of you guys do that. You let fear control your life. Hey, I will tell you, I'm, you know, the only things, you know, I'm really fear of only my wife. But other than that, I'm pretty much don't give a shit about what anybody think about me. Okay, but that's what you have to do. Look, one day you're gonna date a beautiful woman. Yeah, go ask her. You don't know. You miss 100% of the shot you don't take, right? You gotta try, and it's okay. You fail. At least you have think through. At least you have fighted for it. Every problem is not a problem. It's opportunity. The perspective had to change. The opportunity, because if you treat it that way, you have more incentive to get it right. If you treat it as a problem, you're not gonna be as incentive. Very, very important things that you guys have to understand. Okay, so let's finish watching this video. I'm gonna show on desktop. It's gonna be here.
I'm hiring the person who figured it out, even though it took that person longer, even though the person's answer is not as precise. I'm hiring that person. That person knows how to use the mind in a way not previously engaged. You realize when you know how to think, it empowers you far beyond those who know only what.
I always thought like he's one of the best motivation speaker, really, really affecting people's mind. It helped me a lot. And I showed this video to my 7th grade kids. I teach outside of school. Like a lot of people are complaining, oh, I cannot do this problem. Yes, you may not right now, but you will. But you gotta put an effort to it. Don't just rely on people to help you. Like for example, first period, there was a kid named Charlotte Robinson. She's one of my group leader. I love her attitude because last year, like, don't worry, Miss G, I got this. You know, I was like, wait, you're sick for the whole 2 weeks. Are you gonna take this AP exam? He's like, Miss G, I got this. Don't worry, I'm genius. I love her attitude. I don't know if you guys know Charlotte Robinson. She's funny, and she's also so chill. She's really calm. Um, um, and she's doesn't overdo things. She doesn't overstudy. She does 80 to 95% of homework. Sometimes it's like I didn't do it. Okay, I understand that. I asked her this morning. I says, she got her impression wrong. She's that person that spelled a cat with a K-A-T. But it's okay because she sit there. She stay out of the 30 minutes. She said, "I'm trying to really figure things out, but I had problem overcome it." Perfectly respectable. Um, she's awesome. I saw it's a lot of kids first period, a lot of people on this period, a lot of people on other period. You guys are awesome. You guys just need to figure things out and start to use your own thinking and start believing in yourself. Now let's talk about today's stuff. Now I didn't give you answers because I wanted you to treat the opportunity, figure out. Now I will tell you, I'll be the first person to tell you, calculus is the most useless things. But every day in calculus, you learn how to figure things out. And that's the most important part. All right. Let's talk about a spire problem. That's on the SAT. Lucas Lemus last period says, yeah, that was last SAT. I got it wrong. I went over on yesterday in my tutoring session for SAT. Laura ditched me, go to the other group.
Oh, did not. Really? You liked it? I mean, I think I learned like how to just like those geometry questions. But that's maybe I told you yesterday. I was like, I would lost you stream. We can stream it.
I don't want to
You
stream
betrayed
it.
me.
No.
Oh, you didn't stream it? No. Wow, Michelle. Like how about Sophia?
I don't want to show other people a secret where I can charge people $150 an hour.
I'm gonna think about that. Yeah. Okay, yeah, but like you're so smart. Make a profit.
Hey, money comes first. And I'm helping you guys for free, but Ava didn't show up.
Bro.
Bro.
I'm literally coming today, Mr. A. You can't give it out of me. And I would have came. I literally took essay this Saturday.
Yeah, and he didn't show up yesterday.
But it's okay because I'm gonna.
Do you have basketball practice yesterday?
Yeah, I did. Like right after. Literally Wednesdays is when I have right after school.
Oh.
That's why I'm coming today because it's later in the day, so it's like before.
Ava, just so you know, I like your attitude. You always very positive. You bring a lot of positivity into the classroom.
I'm so glad that I approved.
So imagine this shadow problem. This the building. Now, just say for example, you didn't have you have some type of measurement. You can't really measure how tall the building is. And at this time, the sun's right here, casting a shadow at the same location. Like this is sun. This is really ugly sun, but it's casting a shadow to the ground. In this case, the shadow to the ground, and you happen to stand how many feet away to the building. So this is a similar triangle situation, and similar triangle is like this. This is one of the first way on the thing to set up a similar triangle. So how many triangle are there here in this picture? How'd you get 3?
Diagonal line.
What do you mean diagonal line?
Like from that top point to the corner, you can make like 3 triangles.
This is the one,
No, yeah.
right?
Oh.
What's the other one?
I was thinking inside of it.
There's another one. Good.
Yeah.
Where's the third one? You cannot cut.
Already there.
Yeah, just whatever's already. How many triangle are there? 2. Okay, good. All right. Yeah, yeah, you can possibly cut infinite amount of triangle here, but in this point, that this angle is sharing the same angle, the small angle and this big angle is sharing the same. In geometry class, we call it reflexive property. I don't know if you've done that before.
Oh yeah.
Is angle A equal to angle A? And you're like, duh. Of course, angle A is equal to angle A, right? You remember that? In geometry, write down the proof. Very annoying thing.
Yes. The one thing I do remember.
Okay, good. All right, the second angle are congruent because they both 90 degrees. So the 2 angle are the same, the third angle has to be same. It's called third angle theorem. Because if you have 2 angle are the same, the third angle has to be the same. Now, obviously, you're gonna have some, in this case, A, B, C, D, E. You can write triangle ABC is similar to triangle ADE. So they are similar to each other because all angles are the same. So by looking at it, the small triangle ABC is a smaller replica of the bigger triangle. Can you see that? It's not equivalent. It's not congruent. It's congruent at the bottom of the equal sign. But it's not congruent. It's similar. And guess what? We're going to write down says non-capital A and non-capital B. And there is C and D here. So non-capital situation. So what you're gonna do is you're gonna set up a ratio of a smaller triangle of the opposite of adjacent. So in this case, small triangle ABC, what is the opposite of adjacent here? B over A. Yeah, good. B over A. Is equal to what? Okay.
Oh, C
What?
over
No,
A.
B over A.
What? Me and Austin both are, huh?
Wait, C over A plus D.
That's what it was.
Oh my god, you
We both, huh? Me and Austin, I was saying, it was kind of funny.
I'm never gonna answer a question ever again.
She's self-conscious now. All right, so it's not D though. Why is not D? Because D is only small. It's not even the bottom, the base of a triangle. It's A plus D. It's not A times D. It's A plus D. Does that make sense? Now you're gonna have to use this relationship later, if they have similar situation. So in this case, if this is 6 feet tall building, and it's cast 10 feet shadow, and this is a 50, how tall is the building?
Wait, C over 6.
Right? Solve it. Is a person 6 feet tall? Austin's about 6 feet.
No.
How can you tell? Oh wow. I'm sorry, Myra. Myra's like this. No, I'm just kidding.
4 more. History A is a 12.
Nope.
Why not? 36 over 60 is nothing there. 6 over 10. 6 over 10. It's 3 over 5. No? I don't even know what's Yeah, that's 6 over 10 equals x over 6. How is 6? I got that.
Oh, I can't look at the 36. Oh.
I didn't even look at the
Three,
video.
30, not 12.
Wait,
Yeah.
no one learned. I looked at
Oh, I didn't get 30. It's 30. I think 6 times 6 is 12.
Wait, I'm getting
So set up a ratio of a small triangle. 6/10, the opposite of adjacent. Is that okay? Equal to the building, which is the x, over 10 plus 50. So 3/5. Well, actually, I don't even need to do that. I can do 50. So that's going to be 6/10 equal to x over 60. So I can multiply both sides by 60. So then that's going to be 360/10 equal to x. X is equal to 36. So the building is 36 feet tall.
Wait,
Got that.
wait, would you have gotten it wrong if you did like switch the order?
No. If you switch the order 10/6, right, it's equal to 60/x. Same thing, cross multiply, so 10x over 360, x equal to 60. Or 36, sorry. You have to set both of them are different. Okay, so that's one of the relationship you call similar triangle. Now on SAT, similar triangles can set up like this. But they are inverted. They both triangle are replicate to each other because if they are parallel line, this is called vertical angle. Remember this? And what is it called? What? It is congruent, but why they're congruent? There's a name for that.
Alternate.
Alternate what?
Angles.
No.
Interior.
Good. Alternative interior angle. Good. No. She's thinking you're not. She's thinking you're not. Don't laugh at her.
Yeah, I don't laugh.
You didn't come up with a solution, Laura did. So there are two, but they are inverted though. So be careful. This is how you set up the ratio. You're gonna set up a ratio one side over one side to the other side, but they have to be matching. There's a second way that they can set up. On SAT, they can be in this format. On SAT, they can be in this format too. I think one yesterday is this format. Guess what? All three triangles are similar. They can set up in this format. You guys gotta figure out how to set up the ratio, solve for it. Okay, so they in SAT they can be three format. 1, 2, 3. Okay, now we're gonna talk about another thing about SAT. I'm really trying to help you with the SAT.
Wait, can I ask you a question?
Wait, where's the fourth triangle?
It's the half.
Oh.
All three similar. All three triangles are similar. Yeah, somebody was trying to ask me a question.
About the ratios, like a lot of them are also on like.
Yeah, then you gotta translate that word problem into the
But
math
when,
equation.
like, do you always put the ratio like with the one that like coincides with it, or do you? Or sometimes can you do like, for example, on the one that you did, could you do like B over C, and then equals to A over A plus C?
I don't know, but I make a few TikTok video. You can go watch it. Subscribe me. Yeah, math.
Double triangle? Is that 45, 45, 90? Are they both 45, 45?
No, they're not 45, 45, 90.
Oh.
You can tell that's not 45, 45, 90. It's 45, 45, 90 is isosceles right triangle.
Oh.
So they don't look like an equal side.
These questions, you need to have two angles need to be the same, and then also.
Yeah, so those three situations that I can give you at SAT is this first situation.
Yeah.
And yesterday in my review section we did one, and this is the second one. They're inverted, so the way you set up ratio, you gotta match this side to this side, this side to this side,
Okay.
and this side to this side. And this one is all three triangles are the same, so you can set a three different ratio here. They are equal to each other.
And for these questions, for the ratio, you don't include the hypotenuse. It's just
You can include the hypotenuse. It's not a problem to include the hypotenuse. Hypotenuse can be one of them, which is in this one. Sometimes you need to deal with hypotenuse as well. So you can set up a hypotenuse over opposite equal to hypotenuse over opposite.
so just keep it the same.
Keep the same orientation. And if you have question, subscribe to my TikTok. There was three similar. I'm serious right
No,
now.
I'm serious too.
Good.
Yeah, we're serious.
Click like and comment. All right, so I have another situation, another relationship we were talking about. We talk about all kind of relationship. We talk about value. We talk about similar triangle. We talk about Pythagorean identity. So this one is a squared plus b squared is equal to c squared. This one is always show up on SAT as well. You have to know when to use it. Make sure c is a hypotenuse, right? Yesterday I was teaching the same problem yesterday. I teach my son and a group of 6 other kids that in 8th grade. My goal is to make them have perfect score on SAT by end of 8th grade.
Oh.
You want to pay.
I'm broke for 3 years.
Oh. I'm trying to teach you for free right now. Okay, so one of the SAT question I give it to them is there's a rectangle, there's a diagonal line, and my son's like, what is diagonal line? I'm like, you idiot, how come you still don't know it has diagonal line? But that's how you measure a TV from one end to the other end. That's furthest distance from one point to the other point. And so there was 3 root 17, and this side is 3, and they say, hey, what happened to this side? So this is why I'm talking about the CAT and KAT problem. You did this one? You know how to do it?
Yeah.
Good. So my son is like, oh, what is diagonal line? I was like, dude, this is from one point, from one opposite and a rectangle to the other opposite of rectangle. It's the furthest distance. And so he solved the problem, but he did math wrong. And so 5 other kids solved the problem, but their math is, not only math is wrong, their idea is wrong. So I told him, I said, look, I'm proud of you. Usually Asian parents, we don't say we're proud of their kids. But I told him, Gia's like, no, it's not such a thing. You're never gonna get that too much. So what I did is I told him, I'm proud of you because at least you are the right thinking. You set up the Pythagorean identity, you just do your math wrong. Your answer is better wrong answer than other people's wrong answer. So I'm okay with that. Because other people just plug in random number to try it. An answer of this one is actually a very nice number. You go figure out this one. You should be able to figure out this pretty easily.
Yeah.
So that's one relationship. Pythagorean identity is a very, very important relationship. The last relationship is called SOHCAHTOA.
Yes. I remember this.
This is the worst.
It's a good one.
No, I know. Are the easier ones? I know, but like sometimes they twist it.
I taught myself this when I had COVID. Like projection.
You have to really get that H in when you say it because sometimes it confuses.
I literally, when I take the SAT, I rewrite so good.
Oh really?
Yeah, I rewrite out.
Probably.
Now, this can also find out how tall the building is. This is how civil engineer find out how tall the building. They just measure the floor to the building, and they measure from the length of the floor to the instrument. They have instrument to measure the angle. Do you ever seen those? They have like a kind of like camera-ish, and they just angle it, and they can see what's the angle between the floor. It's called angle elevation, by the way. If you know the distance, you know the angle elevation, you can figure out how high the building is using cosine. No, using tangent. Using tangent. So because tangent has opposite over adjacent, and you can figure out. Now on here, in terms of related rate, which is what you're gonna be start doing tomorrow, and actually some today, is the related rate is make sure. Now this is for this lesson only. Make sure constant on the bottom. And you're gonna be like, what doesn't make sense right now? But constant is what I mean is you want to make sure this is a constant for related rate goes. The bottom is always constant. You want to set up a ratio where the constant is on the bottom. And we're gonna talk about what constant is later. And this is also used to find out how fast the angle is changing. Okay, we want to figure out how fast the angle is changing. So right now it doesn't make sense right now, but we're gonna get to that. We're gonna get to that. So what I'm gonna do is I'm gonna go this problem. I'm gonna copy. How do I copy?
Wait, we're not doing SAT anymore.
Okay, so this, I'm gonna upload this file. No, this is the first question of the lesson. How much time I have? That's perfect. I want you to read these questions. If you cannot, just take a picture of that. So this is the beginning of the related rate. Where it says a pebble is dropped into the pond, cause a ripple is falling concentric circle, as shown as a figure 2.34. The radius r of the outer ripple is increasing at a constant of 1 feet per second. When the radius is 4 feet, what's the rate of change of total area A of the disturbed water change? Oh, by the way, there are a few relationships I did not mention yesterday. Did I do cone yesterday?
No.
Okay, so I'm gonna do that. So let me finish with that comb. The comb is gonna be the comb and cylinder. Do you know what's the volume of cylinder, by the way?
4/3.
No. No, cylinder. Pi r squared is the bottom base. Like think about you find out area of a quarter, right? And you stack up the quarter how high. So it's a base times height. Does that make sense? So that's the pi r squared times h. Is that okay? So what's a cone? What's a cone volume? One third. Do you know why it's 1/3? It's a 1/3 of cylinder, yes. Oops. Did I show you this video?
No.
Okay, here's the proof is 1/3. So this is the same height between the cylinder and this cone, and this is, oh, they also have the same circle, same radius of that cone. Okay, so this is exactly 1/3 of a cylinder. So volume is equal to 1/3 pi r squared h. Is that okay? And this is pi r squared h. What's the surface area of a cylinder? Now this one's a little bit harder, which is those top part and bottom part. So I'm gonna draw it out. Top, bottom, plus a rectangle. Right? So it's pi r squared times 2. Is that okay? That's top and bottom. Plus, what's a rectangle? Well, rectangle is like a sheet of paper. Is on the top part, it's gonna be the circumference, which is 2 pi r. And this is h. So it'll be 2 pi r h. Is that okay?
Yep.
Circumference times the height, which is the rectangle piece. And this is pi r squared. Right? Is that okay? Now I'm going to talk about one more thing, sphere. Hold on, let me get the sphere. Sphere is volume equal to 4/3 pi r cubed. What will be the surface area? I already teach you yesterday. What will be a surface area? Think calculus.
It's pi r.
4 pi r squared.
Yeah. 4 pi r squared.
Wait, volume is that r cubed?
Yeah.
All right. So that we talk about, we finish all the relationship about volumes, Pythagorean identity, similar triangle. We finish all that. So we're gonna look at this particular question. We says a pebble is dropped into the pond. It's from concentrate circle. What does that look like? Circle within circle. Thank you. So this circle within circle like this. Is that okay? So the ripple radius is moving at 1 feet per second. You say, okay, what does that mean, 1 feet per second? This 1 feet per second. And also when radius is 1 feet, what will be the total area of disturbing water change? So first thing is find relationship. Because it's called related rate for a reason, we have to know what's the relationship. In this case, what relationship are we talking about? Of all the relationship we talked about yesterday, what's the relationship that we have to do here? Circle what? What is the key word here? Area. So what's the area of a circle? Good. So that's the relationship. The second step usually is you have to assign variable, but variable is already assigned, a and pi r squared, that's fine. So that's usually first step. Second step, assign variables. In this case, there's none. You don't need to assign no variable because the variable is gonna give it. Third step is identify the unknown. Identify the known and unknown. In terms of calculus. So the known is going to be, well, what is the known? The known is the pink part. They says, well, the ripple is increased at 1 feet per second. Let me ask you. I'm going to finish making this video, just watch this part of the video. I'm going to finish this video, but if you want to stay, you can stay. So if I move 1 second, it's going to be here. 2 seconds, it'll be here. 3 seconds, it'll be here. Which second out of those three is the area is gonna change the largest? The third one, because there's more area to change, right? So, but in this case, we also had a constant rate of 1 feet per second. So how do I write that in terms of calculus? It's gonna be d of dt. Why? because that's going to be changing of r over changing of time. That's changing of radius over changing of time.
Use the same thing. It looks like.
Yes, but we don't use delta. Here we have 1 feet per second. Now, what do we want to know? We want to know, look at what we want to know. What's the rate of change of total area? So what would it be? The rate of change of total area, what's that mean? Does that make sense? dA dt, how much fast is it changing? And then this is r is equal to 4. So go ahead and go. I'll finish making this video because you're gonna be late. But then we're gonna finish this part. It's gonna be area equal to pi r squared. We take a derivative with respect to time, so that's gonna be dA dt 2 pi r dr dt. Now all you gotta do is plug in everything. So it'll be 8 pi feet second per second.
Yesterday I took a picture of my homework. So what I did. But this is not right.
Okay.
Maybe you have to do something like Jeff.
You don't remember that? No, I don't remember. Yeah, yeah. No, that was just so fucking loud. Oh,
Bye.
Yeah, yesterday it was crazy. In Greenwald's class, by the time he